Hi everyone, I am Blanis Krimsha William from CSE Department of Rohini College of Engineering. Here the next topic is yield mapping concept. Yield mapping refers to the process of collecting geo-referenced data on crop yield and characteristics such as moisture content while the crop is being harvested. Various methods which are using a range of sensors have been developed for mapping crop yields. The basic components of a grain yield mapping system includes grain flow sensor, grain moisture sensor, clean grain elevator speed sensor, GPS antenna, yield monitor display with a GPS receiver, header position sensor, travel speed sensor. The grain flow sensor determines the grain volume which is harvested. Grain moisture sensor compensates for grain moisture variability. Then clean grain elevator speed sensor used by some mapping systems to improve the accuracy of grain flow measurements. Then GPS antenna receives the satellite signal. Yield monitor display with the GPS receiver. Geo-reference and records the data. Then header position sensor distinguishes measurements logged during turns. Then travel speed sensor determines the distance the combine travels during a certain logging interval. Yield history evaluation. It involves the evaluating the temporal variation of yield distribution within the field is an essential step in defining field areas. Then several approaches that can be used to evaluate temporal effects on yield. One approach is to calculate the relative yield for each point or grid cell. Normalized yield can be defined as the ratio of actual yield to the field average. Then crop production modeling. A broad range of spatially explicit crop response models is needed to evaluate the efficacy of precision agriculture. Many models for predicting how crops respond to climate, nutrients, water, light, and other conditions already exist, yet most of these do not include a spatial component appropriate to precision in agricultural applications. It is a model of simplified representation of a system or a process. Modeling is based on the assumption that any given process can be expressed in a form of mathematical statement or set of statements or a set of statements to depict the real world system. Then modeling is broadly classified into descriptive modeling and explanatory modeling. Descriptive modeling is a mathematical statements or a set of statements which describe the real world phenomena or events and interrelationship between factors. Explanatory modeling. It is described why and how the things work or why and how the phenomena is the way it is. The explanatory modeling are being used as a substitute for full explanatory model nowadays. Thank you.